Hello, welcome to ITW EAE. I'm joined by Tom Conlon. Nice to see you, Tom.
Yeah, thanks for having me again, Trevor.
Yeah.
It's good to see you again.
Yeah, absolutely. Now, we're standing here in front of your Zeva selective soldering system. You've had this for a couple of years, but you've made a few upgrades to it. So we've now got the Zeva M+. Tell me a little bit, what does the M+ stand for?
So we created the Plus because we have some additional enhanced features on that, starting with the closed loop flux control. Very important. We have the majority of our customers in the automotive industry, and automotive is really about process control. So they have been requesting a very good system to have closed loop flux control. We are using a real mass flow meter, so not something which is simulating, and it's really measuring on the fly during the process the amount of flux applied to it. And our software is calculating and compensating for any inaccuracies to that. So that is the first activity we have been doing to enhance the Zeva M as we already had.
So basically it's making sure you're getting complete coverage of flux across the board. Most other systems are just checking for nozzle clogging, basically.
So most of our competitor systems, they are using a laser system for positioning. They're using laser systems to measure the beam, which is then related to the amount of flux. But that is not really requiring or needing the accuracy which a real mass flow meter is doing. And it's also typically not during in live process. So our mass flow meter is really measuring during the fluxing itself and compensating automatically by software.
Is this something that could be retrofitted to existing machines?
Yeah, so it is. That's typically the strategy we always have been applying. When we develop something new, we make that as upgradable to our current, the Zeva platform, but it's also already available on our legacy products. So that's also how we support our customers to that.
Now, I believe you've also been doing some work on your fiducial accuracy and positioning. Try and explain to our viewers a little bit what you've been doing there.
Yeah, so we have been focusing quite heavily on fine pitch because that is the strategy and the trend which is going. The amount of space on the PCB is getting limited and cost is related to that. So the accuracy of positioning is getting increased importance on that. So we have created an option of something, a feature, I would say. It's standard in our machine supporting our strategy for fine pitch, which is measuring accurately any offsets. Realize that fiducial accuracy and correction is something which is different in the selective because also the physical product will have a different temperature. The physical product will have ambient temperature when it starts, and it will be at 120 degrees after preheating, more or less.
Expansion.
And it will be getting expansion. And if you have SMD components really close to where you want to have the through-hole connector or other components, if you will, then that positioning accuracy is getting very, very important. That's why we have the capability of measuring the inaccuracies of the product, and we are compensating automatically for that.
You've got a couple of examples here on boards. Maybe we can bring one of these over.
Yeah, sure.
And show us a little bit about what we're looking at here. Let's start with this one.
So this is a board we have been using ourselves a lot for design of experiments we have been doing with customers. And this board is designed by our engineering team, which has all kinds of different capabilities from pin to pin distance, from 2.5 to what the INEMI roadmap is going to be in 5 years from now, which is 1 mm pin to pin or 40 mil pin to pin.
1 millimeter gap pin to pin.
Pin to pin even, and then with different pad dimensions to really test our process window and capabilities of our machine in order to see where the process window lies. So that is a board we have designed. Because this board design, some of our customers like that so much, we enhanced that design. And we also did all kinds of different copper layers in it, and we did some additional feature on the keep out area testing, where we simulate. Yeah. Okay. Sorry.
I've got a keep out area just around the pins on this device.
Yeah. So you can imagine if that is simulating, that small component is simulating an SMD component, and you're going to hit that with your nozzle, then of course you will have a failure on your PCB. So therefore positioning accuracy is very important for those fine pitch capabilities. We have been doing all kinds of design experiments together with customers, presenting white papers which are available. Even as we speak over here, we are presenting white papers around that.
So, I mean, obviously to help you meet some of these challenges, you've also been developing your nozzle technology. So show us some of the examples you've been doing there.
So our technology is, let's say, based on, we do have the wetted nozzles like most of our competitors have, but already for many years we are using stainless steel nozzles which typically don't wear, they don't need the level of maintenance compared to the wetted nozzles. Stainless steel with the chromium coating, they will last forever also in the lead-free environment. However, with the new capabilities of 3D printing, we have been looking at all kinds of different capabilities. First step we have been doing, can we copy this nozzle with 3D printing technology? And 5 years ago it was extremely expensive, but we confirmed that it was possible, even with the chromium coating we have been doing.
Show us an example.
Yeah, based on that experience, we have been doing also different shapes on that. So this is a trapezium nozzle. In our physical equipment, we currently have a square nozzle, and those nozzles have some pros and some cons as well.
You can just see the trapezium
Yeah.
shape on
Yeah. And the good thing about 3D printing on itself, they are slightly more expensive than conventional technology right now. It will become less expensive, but it doesn't matter what kind of shape you're getting, the price is pretty much equal. And based on that, we have been developing what we call the 3D twin nozzle, which is ultimately 2 diameters of nozzles and integrated into one. And that benefit for a customer is that if you have the small keep out areas and S&D components, you can have the small diameter of nozzle. But if you have a little bit more space or a multiple row connector, you just rotate the nozzle and we will solder that bigger nozzle, reducing cycle time.
So doing both functions with one nozzle will reduce the cycle time because you don't have to do the changeover.
And changeover, and the competitor solutions is 2 pots. 2 pots also need more maintenance, need to have more wear. So that is the benefit of this nozzle compared to what currently is available. And I believe we are not out of our development. With 3D printing, there is so much more available that there is so much possibilities that we still have to do a lot of testing. So I'm pretty sure more to come.
You can do these things on demand to any shape a customer needs.
Yeah, exactly. So
You've got a fairly novel little system as well for being able to separate the when you go down to the fine pitch.
Yeah.
Can you show us that?
So currently the SSC, as we call it, that's a solder drainage conditioner, which is more like a hot nitrogen knife, which is removing the surface tension from the solder during the fine pitch bridging. So this is where the nitrogen will be supplied. It's just a small flow. It's not like a tremendous flow, just a small flow going through that area. It is preheated nitrogen, so the nitrogen temperature is above temperature, and then it can leave at the small pitch connector. And as an example, we are doing live soldering this show. So this PCBs will be soldered live on the 40 mil or 1 mm pin-to-pin distance, and we are running that over here at the show with a relatively weak flux with some nitrogen we had to get approval for, and we are running this successfully every hour. So that SSC is working really well for fine pitch solutions.
Well, Ton, a lot of innovation being packed into this M Plus machine. I want to thank you for sharing it with us today.
Okay, thank you for having me, Trevor. Thanks.